Today you'll be learning about circle vocabulary and relationships. Essential question: what are some key terms regarding circles and how do these terms relate? So we'll start off with these general definitions involving circles, and the first one is circle. So go ahead and just try your best to draw a circle. Okay. And something that you ought to know, all the points that compose this outline of the circle, every single one of them that form the circle's outer line, form the circle's line, I guess, form the circle's curve, they're an equal distance from the center point. So this guy is the same distance from here to here as this guy is the same distance from here to here, okay? All these that form the outer edge are the same distance from their standpoint to the center of the circle, okay? So since I had kind of trouble spitting that out, here's what I'm trying to say. All the points that form the circle's outline are an equal distance from the center point. Okay, so right here in the very, very center, all these points are an equal distance from the center point. Okay? All right, semicircle. I'm just going to draw it. It's half of a circle. And a semicircle doesn't have to necessarily look like that. You can also draw a semicircle like that, or it looks like that, or like that. That's still a semicircle no matter how you turn it. All right, radius of a circle. So if I had a circle, and pretend it's a great, super nice, beautiful circle. A radius, it's, from distance from that very center to any one of those outer points. Okay, so from there to there, or from there to there, or from there to right there, or from there to there. Those are all the radius of the circle. The distance from the center of a circle to any point on the circle's outline. And a nice little fun fact, the radius is half the length of the circle's diameter. Okay, so if you're like, what's the diameter? The diameter of a circle is all the way across like that. It's got to pass through the center. Sorry, that doesn't look like it's a center. It's got to pass through the very center like that. So that could be the diameter. You could say, oh, the diameter is from here to here. As long as it passes through that center part of the very center of the circle. You could say, no, this is the diameter. No, this is the diameter. Okay? The diameter passes through the center of the circle, and it goes from one part of that curve to the very other part of the curve. Okay? So it's a line segment that passes through the center of a circle. It's double the length of the radius. The diameter is double the length of the radius. Okay. Next up we have circumference. So if I drew a beautiful circle, the circumference, it's from Loop all the way around, the distance all the way around that outer curve. Okay, so that's really hard to look at. So it's really just the outside. Okay, and I was just trying to draw like, hey, it's from here to here. Those are supposed to be arrows, and they're supposed to imply that it's the distance all the way around. So luckily you don't have to rely on my artwork, because I'm going to write the definition right here. It's the distance around the outline of a circle. Okay. And really, it's the circle's perimeter. But remember, we don't call a circle as perimeter, the perimeter, you call it the circumference, because it's special. Okay, and a nice way that, a way that I used to memorize this is like, I've showed you this already. If you had a circle, pretend that's a circle. And you're like, oh, the distance all the way around. Look, it looks like a C for circumference. When you're drawing it, oh, C for circumference, the distance all the way around. Okay. Pi. Pi is the ratio between a circle's circumference and diameter. Okay. So here's what I would write. It is a circle's circumference. So this measurement around there divided by its diameter. Okay, so you take this outer, the outer length, its circumference, and divide it by that length all the way across that distance. Okay, and you know what you're always going to get? You're going to always get pi. So if you take the circumference of any circle and divide it by the diameter of that same circle, you're going to get pi. It's kind of mind-blowing that any circle, that's the relationship that you'll get. So if you take any circle's circumference divided by diameter, it will equal pi. And pi, this is like the rounded version of pi. Pi equals, if you want to see the numbers, 3.1415265897. I'm continuing it. 7932386, and that goes on forever and ever and ever. So I don't have forever and ever and ever to write it down, so that's where I'm going to stop. Okay, so pi's digits go on forever. Sorry, I can't write with one arm not holding the paper. Pi's digits go on forever without repeating. So it's an irrational number. So if you're like, what the heck did Hopkins just say, an irrational number? So an irrational number, it's any number that goes on forever and ever and ever without a pattern and without repeating. You know, without pattern means it doesn't have any sort of cute little pattern. So like pi right here, that's an irrational number. You'll see it fills up the entire screen. I know it goes on forever and ever and ever, but my calculator had to cut it off some point, so that's where it cut it off. But you'll see there's no pattern. It's not repeating, so that is an irrational number. Another one that I can think of right off the bat is the square root of 2. So you write 2 and then that. So you write here that's definitely an irrational number. Square root of 3, yeah, that's an irrational number. Probably, yeah, square root of 7, irrational number. Here's an example of a number that's not irrational. So if they're not irrational, they're called a rational number. So like 8, that's a rational number. Okay. 1/3. See, it's going on forever and ever, but it's got a nice pattern. Okay. We'll go That right there, that's got a nice pattern, and it would still continue with the 8ths, but it just rounded because my calculator had to stop. Okay, so those are examples of rational numbers when they have a nice repeating decimal that's got a nice pattern, or if the decimal just stops. That's a nice rational number, okay? Irrational is where it's like psycho-crazy like that, okay? And that's really an 8th grade standard, but there's a chance it could be on like the NUIA or something once you get up into those, you know, those upper level grades. For your summary, I want you to complete this sentence. If you take any circle's circumference and divide it by its diameter, it will equal... Okay. Now we're going to do an activity. You will find the radius, diameter, and circumference. Wait, just kidding. Oh, and the circumference divided by the diameter of various objects that are in the shape of a circle. So what supplies will you need? Well, you'll probably need a pencil so you can write it down and track it in this table. You're going to take one of these. And I think I already have one over there. I'll just grab one now. And you'll see on the paper that you have all this, like this column right here. Okay, you'll write down your supplies, you need a pencil and this thing. And you'll fill in the blanks with the following information that you will collect about each object. And you're like, well, there's no objects right there. But you have to collect data on it. And you probably can see the whiteboard from where you're sitting. And if not, I'll show you again. So this activity, you got to select any objects for this, any seven objects for the activity. So here are the titles of what you will be measuring. So you're like, oh, a wide base of a big water jug. What's that? That's this. This is the wide base of the big water jug. You'll be measuring that if that's one of the ones you select. So there's quite a cute little list up there of things that you will measure. So you and your partner will pick just 7. And if you're like, oh my gosh, everyone wants to do this one and I'm waiting in line for it, then don't do that one. Don't start with that. Okay? So anyway, I'm going to go ahead and try to demonstrate with one hand how to do this. Right here. Lid of cookie tin. Okay? And the circumference. And if you're like, crud, I forgot what the circumference was. It's a great thing that you have these definitions right there. So you will take that. And listen, you need to measure in the centimeter side, okay? I want us to use centimeters. So you will do this, and you'll see it's very difficult for me to do one-handed, and it's great that you have a partner to help hold it. Now you want to be consistent in your measuring. So you don't want to make it very loose when you're doing this. You want to make it, it's called taut, where it's kind of like, it's tight. And you're going to measure it. So this is not really the actual measurement because I'm not really measuring it because it's very, I can't do it one-handed. So let's pretend when I did it, this is, look, it's rolling away. When I did it, let's pretend I got it to be like, I can't even see, like right, I can't even do this with one hand, sorry. Thanks for your patience. Crazy teacher here. Okay, let's say it gets to be like right there. Okay, right there. So that would be 31.5, 31.6, 31.7, okay? So I'd write, this is not real, 31.7 centimeters, okay? And now the radius, if you're like, what's the radius? Well, the radius is the distance from here to here. And if you're like, oh, I don't know exactly what the center is, you might just want to skip to the diameter. That's probably what I would do. So take your diameter, and this isn't real either because I'm making it up. Okay, see, I'm not holding it taut and it's crooked and it's horribly messed. Let's pretend it's 18.7 for the diameter. Okay, so since the radius is half the diameter, so you'd take 18.7 and divide it by 2 and get your answer right there. Now, you take the circumference divided by the diameter. So you're going to take this number, divide it by this number, and you know what you're going to get? You're going to get 3.14159, blah, blah, blah. Now listen, when you do this, you're probably not going to get exactly pi, and here are the reasons why. First off, there could be an error in your measuring, okay? Like, depending on how you do it, like no one's going to measure this perfectly exact. So that's why you're going to get pretty close, hopefully, to 3.14159, blah, 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 but you're not going to get exactly pi. You're supposed to, but there are errors in, you know, in measuring. And who knows, this might not even be a perfectly manufactured circle. This could be just a tiny, tiny bit off. Okay? But the point that I'm trying to drive home is I need you to know this vocab, and I need you to know that circumference divided by diameter is supposed to equal pi, exactly pi. Okay? So then you will answer this question, and this is the part where we're going to continue. Okay, you learned that circumference divided by diameter equals pi. Okay, and you should have also learned that 2 times pi times the radius, that's going to give you the circumference. And if you're like, I don't remember that, that was on the notes you took when we talked about area and perimeter when we first started the geometry unit. So it's in there, I promise. Okay? So you're going to combine your knowledge of what you know about solving equations to answer the following. So it says, find the circumference of a circle whose diameter is 14 centimeters. And you can use this formula or this formula. It's good to memorize both, but if you're like, I only have enough room in my brain to memorize that, that's cool. And if you're like, I only have room in my brain to memorize that, that's cool too. Because I'm going to show you how to do both ways, because you know there's multiple ways to do things in math. So we got to find the circumference of a circle whose diameter is 14 centimeters. I mean, if you need to, you could draw a picture of what that would look like, but I know the diameter is the distance all the way across, like that. So I'm going to, on this side, I'm going to use this equation. And instead of writing out circumference divided by diameter, I'm going to use C divided by D equals pi. Okay? So seeing that right there, we got to find the circumference. So I'm going to keep that as a letter C. I'm going to keep it as a variable. It tells me the diameter is 14, so I'm going to just plug it in. And that's going to equal pi. Well, you know pi is a number, so don't freak out. I can't find my calculator. I'm freaking out. Okay, here it is. So to solve for C, see how we had divided by 14? So the opposite of dividing by 14 when you built it is to multiply by 14. So 14 divided by 14 is 1. 1 times C is C. So C is equal to 14 times pi. Okay? And that's supposed to be in centimeters. And if the directions want you to, you should give me what that is. So 14 times pi. You can go 14 times 3.14, or if you have the pi button, don't be lazy, just press it. There we go. So it's approximately 43 and 98 centimeters. Okay, and if you're like, oh, you know, I like the other formula better, then use it. I'm going to segregate right there. 2 pi r equals circumference. Okay, let's just plug it in. So 2, we have the 2, that's constant, the pi is constant, and then radius, I don't see radius, oh, but you know in your brain that radius is half the diameter, so half of 14 is 7. That's going to give you the circumference. So 2 times 7 is 14, pi equals C, and we know that 14 pi is approximately 43.98 centimeters. This is the most exact answer. It's saying take 14 times pi, you know, real pi. This is with the rounded one, okay? So you'll see we've got the same answer because they were equally the same. Okay, this one right here. You know what I should have done? I should have done this one in red, so it's all matching. Okay, so C divided by D equals pi. Let's plug it in. The circumference of the circle. Okay, it's got a diameter of 16. Nice, they tell us the diameter. We don't know the circumference. I'm going to keep it a variable. We know the diameter, it's 16, and that's going to equal pi. So to solve for C, we multiply by 16. 16 divided by 16 is 1. 1 times C is C. C is equal to exactly 16 pi, which is approximately, if you go 16 times pi, it should be 50.27 inches, approximately. Okay, now the other one, if you like the other one better. But for the notes, you got to write both, so you get practice with both. Okay, and after this problem, you're going to literally stop the video and try it yourself so you can study. Okay, so that was the formula. You got to probably memorize that. Radius. So 2 times pi times the radius. Radius is half the diameter, so if the diameter is 16, the radius is 8. So 2 times 8 is 16 pi. That's times pi, and that's circumference. And then circumference is going to be approximately 50.27 inches. Okay, same exact answer. Okay, you're pausing it, you're trying it. Try it both ways. Here's the answers. C divided by D equals pi. And the circumference of a circle, find the circumference of a circle if the radius is 14 centimeters. So I don't know, I know the radius, I don't know the diameter until I go radius times 2. So circumference is equal to 28, which would equal pi. Circumference divided by diameter will equal pi, so I'm going to times by 28 on both sides. 28 divided by 28 is 1. 1 times C is C. That's going to equal exactly 28 pi, which is approximately, when I go 28 times pi, going to be 87.96 centimeters. Okay? Now for the other way, 2 pi r equals the circumference. So 2 times pi, the radius is 14. That's going to equal circumference. 2 times 14 is 28. Don't forget to times it by pi. Okay, there's your circumference, and circumference is going to be approximately 28 times pi was 87.96 centimeters. And double check that because I could be wrong. Alright, number 4. Find the perimeter of a semicircle. Okay, they're trying to trick me here. I know perimeter means like circumference. So find the perimeter of a semicircle that has a diameter of 17 inches. Oh, this is also trying to mess with me. Semicircle. Perimeter of a semicircle. So I'm going to just draw it over here. There's a semicircle, and it's telling me the diameter is 17 inches. Okay, so that's what I'm going to use as kind of my guide. So I can go circumference divided by diameter equals pi. Okay, so this is for a whole circle. At the very end, I got to divide it by 2 to get the semicircle. So the circumference is, I don't know, but the diameter is 17. Circumference divided by diameter is supposed to equal pi, or will equal pi, times 17 times 17. 17 divided by 17 is 1. So the circumference is equal to 17 pi. Exactly, but listen, that's for a whole circle's perimeter, a whole circle circumference. You need to divide it by 2 for the semicircle. Okay? Wait, I'm just going to, semicircle would be 17 pi divided by 2. When you do that all out in your calculator, I don't remember what that is. 17 times pi equals that. Now I've got to divide it by 2 because it's a semicircle. Okay, so that's what I got. 26.70, is it inches? Inches. Okay. Now let's do it with the other formula. 2 pi r equals circumference. So for the whole circle, 2 pi, okay, the radius is going to be half of 17. Half of 17 is 8.5. So 8.5 times 2 is 17. 17 pi equals the circumference of a full circle. Okay, we need to divide that by 2 to get half of a circle. So let's go ahead and figure this out. 17 pi is 17 pi, I don't know, I forgot. That. 53.41. That's for the full circle's circumference, so we gotta divide it by 2. So it's approximately, or actually, yeah, look at that. Now I still have it in my calculator, so I'm just gonna go divide by 2. I'm not gonna clear my calculator. That takes too long. 26.70. No. Can't. 26.70 inches. Okay? Alright, so your task really is to memorize these words, and you need to know that or that, okay? Because it's going to be assessed. It's a 7th grade standard, of course. For your summary, I want you to answer this question. So if 2 times pi times the radius is equal to the circumference of a circle, what does pi times the diameter equal? Think about it.